In this video, I would like to explain the concept of enthalpy. What is enthalpy? Enthalpy is symbolized with a capital H, also called heat content. So it may be defined in different manner. Now, we can see one type of definition. It is the sum of internal energy of matter and the product of its volume multiplied by the pressure. Enthalpy is defined by the following equation: H is equal to U plus PV. Sometimes it is indicated with P delta V. So enthalpy is a quantifiable state function. And the total enthalpy of a system cannot be measured directly. The enthalpy change of a system is measured instead. Okay, so enthalpy change of a system can be measured. So we will see the things in next slides. So enthalpy of a system includes the internal energy and work. So H is equal to U plus PV. This U is the internal energy and PV is sometimes termed as P delta V, pressure into the change in volume. So here the work is performed only if there is a volume change. So W is equal to P into delta V. So P delta V can be equated to the work done by the system. So enthalpy of a system includes the internal energy and work. Work is external, can be considered as the external energy. So here a different type of definition. We could say that as in other words, enthalpy is the amount of heat energy absorbed or required by the system to cause a change in the system, or the amount of heat released by the system, or that may expelled by the system as a result of a change in the system. So there may be so many changes that can happen in a system. So like endothermic, exothermic, or absorption of heat or release of heat. Like that, there may be several changes can be done in the system. So here enthalpy is the amount of heat absorbed or required by the system to cause a change in the system, or amount of heat produced or released by the system. So if delta H is greater than 0, what is delta H? Change in enthalpy. Change in enthalpy is greater than 0. So that means there is some change in enthalpy. Some change is happening. Then that particular system will be endothermic. That means absorbs heat energy. If the change in enthalpy is less than 0, if we are getting the value in negative, then the system will be of exothermic, that expels heat, releases heat. So the process is spontaneous. Clear? So H is equal to U plus PV, and delta H is change in enthalpy, that is heat added to or removed from the system, that is the change. H is just representing enthalpy. Delta H is representing the change in the enthalpy. Now delta U here, what is U? Is internal energy. Delta U is change in internal energy. What kind of change that occurs in internal energy. And here PV is P is pressure, V is volume, and P delta V is the work done, actual work done by the system. Okay, so work done by the system. So this enthalpy can be defined in this manner also. H is equal to enthalpy, or again equal to heat content. Change in enthalpy heat given off or absorbed by the system or the reaction. So delta H is H products, enthalpy of products minus enthalpy of reactants. For we have already seen exothermic process. For exothermic process, change in enthalpy is less than 0. Endothermic process, the change in enthalpy will be greater than 0. And here H products, enthalpy of product will be less than enthalpy of reactants. And in the case of exothermic reaction, enthalpy of product is less than enthalpy of reactants. In the case of endothermic reaction, the enthalpy of products will be greater than the enthalpy of reactants. Okay, so exo means heat is released and endo means heat is taken up by the system. Okay, so H2, here we can see some two reactions. H2 of G gas plus F2 of G gives HF, and H2 of G, when we heat up that content, there will be a splitting of two hydrogens, this gas. Okay, so here enthalpy is a state function. Enthalpy is what kind of function it is? Enthalpy is a state function. We have already seen several definitions. So here H is equal to E plus PV. We already seen that. For a purpose, we are seeing that since internal energy, pressure, volume are all state functions, enthalpy is also a state function. Okay. Enthalpy, internal energy, pressure and volume are all state functions, so enthalpy is also a state function. Then what is a state function? That should be known. Thermodynamic state function. A state function is defined as a property of a system that only depends on the initial and final state of the system. Okay, that is the main concept. There are two parts of the definition. For state function, the definition is of two parts. One is that only depends on the initial and final state of the system, and it is independent of the path followed in getting from one to another. This is the second part of the definition. It is independent of the path followed in getting from one to the other. Okay. Enthalpy and internal energy. Okay. Now we have to see what is that. Delta H is equal to delta U plus P delta V. That is a state function. And delta U is equal to delta Q minus P delta V. Okay. So delta U is equal to Q minus P delta V. Delta Q is equal to delta U plus P delta V. Here delta Q is a path function. Delta Q is a path function. Delta H is equal to delta U plus P delta V, and delta U is delta Q minus P delta V. So here delta U will be equal to delta Q if there is no change in volume. If there is no change in volume, then delta V will be equal to 0, and when delta V when it is 0, P delta V term, entire term will be 0. So delta U will be equal to delta Q. That is of this first diagram shows. Now in the case of delta H is equal to, if the work change in volume happens like this in this diagram, change in volume happens, then there will be a value for delta V, and P delta V work done will be the expansion of this gaseous molecule. So in this case, the delta H will be equal to delta U plus P delta V. Okay, so in this case there is no expansion of volume. Here we have the expansion of volume, so there will be a value for delta V, so that P delta V. Okay, that is what explained here through this diagram. So here delta H is equal to delta U plus P delta V, And in the second step, delta H is equal to, instead of internal energy change, we are having delta Q minus P delta V here, as it is given here, plus P delta V. Okay, so if minus P delta V and plus P delta V are cancelled out, then delta H is equal to delta Q. Change in enthalpy will be equal to change in the quantity of heat absorbed. Okay, so what is enthalpy? Enthalpy and internal energy need not be equal. Okay, change in enthalpy is equal to change in internal energy plus some other value, P delta V. If this term becomes 0, then what will happen? This delta H will be equal to delta U. Okay, so delta H will also be equal to delta Q. Next, enthalpy versus internal energy. So this is the conclusive part. Enthalpy is the heat energy that is being absorbed or evolved during the progression of a chemical reaction. But in the case of internal energy of a system, it is the sum of potential energy and kinetic energy of the system. Enthalpy is calculated, H is equal to U plus PV, and in the case of change in internal energy, it is calculated like this, delta U is equal to Q plus W. It is defined as the relationship between the system and the surrounding. Which one is enthalpy is defined as the relationship between the system and the surrounding. And in the case of internal energy, it is defined as the total energy in a system. It is defined as the total energy in a system. So with this we can conclude the definition and understanding concept of enthalpy. Thank you.